guys. So, on our board here, all right, we're going to do a quick check review. That's the paper I just handed out. We're going to do that one together so that I can kind of refresh your memory on some things that we learned about at the beginning of January, okay? And then there's going to be a test review on Canvas. That's going to be something that you do on your own time. And all it is it's a pool of questions over what we're going to talk about on our quick check. And you get to kind of go through almost like it's simulating a test. And then at the end, you get to see your full results. You get to see which ones you missed, and it tells you the correct answer, okay? So you can do that review as many times as you want, the one on Canvas, okay? You can do it as many times as you want. If you complete it, and I can tell that you're really working, maybe you did it like 3 times, or maybe you made like a 98 on it, I'm going to give you extra points on your test tomorrow, okay? So you don't get extra points on this paper copy, but I want you to have it so that I can go over problems with you. You do get extra points by doing the test review that is on Canvas. And I'll show you that link in just a second after we finish this paper. Okay? Our test is tomorrow. You're going to have 25 multiple choice questions, and you're going to have that vocabulary portion. Remember, if you turn in your written vocabulary words, you get extra points on the vocabulary portion. Okay?
Do we still have today to do that too?
Do we what?
Do we still have today to do that?
Yes. You can turn it in tomorrow. All right, let me get this pulled up over here. There we go. And this is where we are at. Maybe I shouldn't scroll or zoom in that much. All right, so let me erase some smiley faces. We're just going to go through this quick check quickly, which is why it's called a quick check, and answer these questions, okay? So our first topic that we talked about was frame of reference. Why do we need a frame of reference when we're looking at the motion of an object? Yeah, so that we can determine its motion, okay? So a frame of reference allows us to determine motion of an object. Okay, the frame of reference allows us to determine motion of an object. All right, and then we have distance and displacement, okay? Distance distance includes twists and turns, I'm sorry. I got that confused. Distance includes twists and turns. Displacement ignores twists and turns. Yep, you were completely correct. That was my fault. They have a really bad glare. So let's see if I can fix that at all. That's better. Okay, so this question is about distance and displacement. Sandra walks around in a circle 3 times. Okay, so here's a circle. She walks around it 3 times. She starts and ends in the same spot. Okay, so say that she starts here and ends here. Okay, and the circle is 30 meters around. All right, what is her distance? How would I figure out her total distance if she walked around that circle?
30 times 3.
Yes, okay, so the circle itself is 30. She did that 3 times. So 30 times 3 is? 90 meters is her distance. What would her displacement be?
It would be 0, yeah.
It'd be 0 because why?
The end and the start are the same.
Yes, okay, so her displacement is 0 meters because she started and ended in the same spot. Okay? So moving on to the next part is speed and velocity. Let me see if I can get this where I want it. That works. All right, so speed and velocity, they kind of go hand in hand. we calculate them the same way, which is why I put them in the same grouping here. Okay? What is my speed formula?
Distance divided by time.
Distance divided by time. Okay, so S equals, I'm going to write DIST divided by time. We have a speed triangle that we used. STD. And that helped us calculate some things. What's my velocity formula?
Displacement divided by time?
Yep, displacement. So I'm going to put DISP divided by time. Displacement divided by time. And we have the exact same triangle. We put a V instead of an S. Okay? So the big kicker in these two is that speed is going to take into account distance, and velocity is going to take into account displacement. Okay, those are the main differences there. Calculations are the same. Okay, so let's work two of these problems using our triangle. Our car traveled 150 kilometers. What kind of variable is this? Distance. In 3.5 hours. What kind of variable is that? Time. What was its average speed in kilometers per hour? So I'm looking for speed, okay? I'm looking for S. What am I going to do with D and T?
You're going to divide them.
I'm going to divide, okay? So to find the average speed, I'm going to do distance, which is 150 kilometers, divided by time, which was 3.5 hours. And I get 42.8 kilometers per hour. Okay, keep in mind that this portion of the test will be multiple choice. Okay, so you will have answer choices that you can look at, all right, just to kind of narrow them down and things like that. All right, number 2, what distance will a bus go if it's traveling at a rate of 75 kilometers per hour? What kind of variable is that? Kilometers per hour. Velocity or speed, okay? So this could be velocity or it can be speed. And what is 2.4 hours? Time. Okay, so this right here, whoa, I did not circle the 2. This right here is my time. Okay, so if I have velocity and I have time, I'm looking for distance. What am I going to do with those two? I'm going to multiply because in my triangle, they're beside each other. Okay, so I'm going to do 75 kilometers per hour times 2.4 hours. And you get 180 kilometers. Okay, tomorrow on the test, you will have these formulas given to you. Okay, there's going to be like an anchor chart, and I'll show you on the screen in just a second what that looks like. So don't think you have to memorize those triangles, but they are going to be available for you on the test. Okay, so that's our speed and velocity portion. Next, we have acceleration. This is one of the most recent things that we've learned about. Alright, so the first thing that it wants us to do is give all 3 acceleration formulas. Okay? So we have an A equals, we have a VF equals, and we have a T equals. Alright? These will be given to you on the test tomorrow as well. Okay? So our A equals equation is VF minus VI divided by the change in time, divided by delta T. We have our VF equals equation. So VF equals VI plus A multiplied by T. Okay, so on this one, you would multiply first, acceleration times time, and then add your initial velocity. On this one, I need you to subtract first, so VF minus VI, enter, and then divide by your time. Okay? And then our last formula is T equals VF minus VI divided by A. Okay, so those are all three of our acceleration formulas. What does VI stand for? Initial velocity. That's what we're going to write in this blank right here. Initial velocity. So the starting velocity, okay? And what's usually the units for that, for velocity? Meters per second, okay? Meters per second is usually what we calculate velocity in. What does VF stand for? Your final velocity. So where did you end up velocity-wise? The ending velocity. Okay, velocity once again is measured in meters per second. And what do we think the A stands for? Absolutely it does. Acceleration. What kind of unit does it have? Meters per second squared. Yes. Okay, so this is ms squared, and that's how we differentiate between acceleration and our velocities. Okay, acceleration is the only one with a squared unit. Meters per second squared. Okay? If we flip this on the back, we're going to use these acceleration equations to solve two problems. Okay? I'll keep those formulas up there so that we can use them. So it says a jogger has a speed of 4.0 meters per second. After 5 seconds pass, he has a speed of 9 meters per second. What is his acceleration? Okay, so I'm looking for A. So what equation am I going to use?
Acceleration.
I'm going to use A equals, yes. Okay? What variable is 4.0?
The starting velocity.
Yes, so VI. Okay? What is 5 seconds?
The time.
The time. And what is 9 meters per second?
The final.
The final velocity. So now, I'm looking for A. I'm going to use my A equals equation, and I'm going to plug in these numbers to that equation. Okay, so VF minus VI. So VF goes first, so I'm going to do 9 minus 4 divided by T, which is 5. Okay? What's 9 minus 4?
Is 5.
5. What's 5 divided by 5?
1.
1. So our acceleration is 1 meters per second squared because A is squared. Okay? Make sure on that you are subtracting first. Okay? So 9 minus 4, enter, divided by 5, enter whenever you go to use your calculator. Okay? Number 2. A scooter travels at 5 meters per second. After 2 seconds, the motorcycle travels at 19. Wow, we switched rides there. That was a typo on Coach Seegert's part. Went from a scooter to a motorcycle. Didn't know you could do that. Okay. So after 2 seconds, the motorcycle travels at 19 meters per second. Which of the following is the average acceleration of the scooter? We switched again. Okay, so we are calculating acceleration again. So I'm going to use the same formula. All right. What is my VF? What was my final velocity? 19. What is my VI? 5. And then my time was 2.
14. 8. 7.
Yep. So 19 minus 5 is 14. 14 divided by 2 is 7. And we're looking for A equals, so meters per second squared. Okay, so that's our acceleration formula. We're almost done with the quick check. Okay? The most recent thing that we have talked about are these distance time graphs. So let's look at what these lines mean. All right, so on a distance time graph, it says describe what each graph is showing. What does this line represent?
It's
A constant speed. Okay, so this graph is constant speed. What is that second graph representing?
At rest.
At rest. The flat horizontal line is at rest. Okay, what are the two graphs with curves showing us? Acceleration, okay, but we're going to be a little bit more specific. So this is going to be when something is slowing down. Okay, so this upwards curve like that is slowing down. All right, so we would say it's deceleration, which just means slowing down. Okay, that far right one, it's still a curve, so it's not constant. It's going to be acceleration speeding up. Okay, so this is acceleration speeding up. Okay, so if you have a curve, it's kind of starting to look like a rainbow or something, all right, then you are slowing down. A curve that's going under is speeding up. Okay, but they both show change in speed. They both show a type of acceleration. Okay? There are going to be multiple choice questions kind of similar to this where you have a picture of a graph and it wants to know what that type of line represents. Okay? On this one, we're going to look at this distance time graph and calculate speed. Okay? What's my formula for speed again?
Distance divided by time.
Distance divided by time. So what is the total distance that this graph took us? 4. Okay? So this graph went 4 meters. So distance equals 4.
20 seconds.
And 20 seconds is my final time. Okay? So whenever it says what's the average speed of the toy car, you're just going to get its distance divided by time. So 4 divided by 20. Is it 0.5?
0.2.
0.2?
Yes.
0.2 meters per second. Thank you, Brooke. Okay, so that's how you would find the speed off of a distance time graph. Okay, last little portion that's going to be on our test is independent and dependent. Okay, we use the term dry mix to help us. All right. Basically, what you need to know is whatever you manipulate in the experiment, whatever you change each trial is your independent. The result of those trials is your dependent. Okay? So, Cody wants to see which wheels make his bicycle go faster. What is he going to change each trial? The wheels. So that is his independent. So wheels is the independent. What's he trying to see from these wheels?
How fast they're going to make them go.
Okay, so the speed of the bicycle would be your dependent. Okay? So I'll circle faster. That'll be your dependent variable, if the bike is faster or not. Okay? Margie is measuring which brand of sugar makes her cookies taste the best. Okay, so what is she going to change each trial?
The brand of sugar.
The brand of sugar. So what variable is that?
The independent.
The independent. What is dependent on that sugar?
The taste.
The taste. Okay? Taste is the dependent. Okay, so we just did 2 examples of each topic pretty much. The only thing that's not on here that's on the test is vocabulary. Okay? So now let me show you on Canvas that test review that you do on your own. Let me get my student view on. Let me change the angle of this so that they can see the whole screen. Alright, so if you scroll down to Thursday, here's our Unit 7 test review, and this just tells you you have unlimited attempts to take it. The higher score you get on it, the more points I'm going to add to your test tomorrow. Okay? I've already told you guys that. So if you click on this Unit 7 test review, here is that like anchor chart I was telling you about. This is the same one that you're going to get to use on tomorrow's test. Okay? So it has your speed triangle. It has your velocity triangle. I put dry mix on there to help you remember dependent and independent. There's all of your acceleration formulas. This doesn't tell you specifics about graphs, but it's just kind of a reminder about these graphs and what each line means. Okay? What would you say phase 1 is? Constant speed. What about phase 2?
Rest.
And what about 3? Deceleration. You know it's some form of acceleration, okay, because it's a curve. And then we have a little graphic here showing you the difference between distance and displacement. Okay? So you get to use that on this test review. So once you go through and take it, it's kind of pulling questions from a question bank. So if you take it a second time, you might not get the same 2 acceleration problems. You might get different ones. Okay? It is a pretty thorough test review on purpose. Okay? For you to get as much practice answering these questions as you possibly can. Okay? Does that sound like a plan? Alright? So what you're doing today is you are going to do this test review. Okay? I want everybody to at least do it once. Alright? You're doing this test review on your own. And then if you want to do it again, you can. If you want to work on your vocabulary, you can. Okay? Whatever you need to get ready to do to prepare for tomorrow's test. Everybody good to go? Awesome.